Hello, welcome to Chapter 2 of Trig. I wanted to take a few minutes to help you walk through your My Math Lab and look at some of the features that we have here. So I'm going to start here with the e-text contents, and I'm going to click on Chapter 2, and I'm going to click on Section 2.1, and I'm going to view the e-text. Now there's also a video, but I'm going to look at the e-text today and just show you what's available here. When this opens up for us, we have a textbook that we can maneuver around in. Underneath this, we have the arrows where we can go forward, go backward. I want you to utilize that because they've got really good examples. They've got everything spelled out for you right there. It's free. When you purchase the code for the class, you purchased access to that. Now, I've taken and printed off a copy. It is not nearly as good as looking at what you have on the screen, but I'm just going to go over a few things with you in Chapter 2, so just bear with me here. It starts by talking about the sign, and we're doing the graph of the sign function. And if you're looking on your computer, then you don't have this watermark on there. I'm not printing this for distribution. I'm just using it to educate with. But anyway, they have taken and gone through. These are the values on the unit circle. And they have found the value of the sign, which is the y value, for each of those critical points around the unit circle. And they've made us a graph. And they go on down here and they say, okay, if you use each of those as an ordered pair, the location on the unit circle and the y value for that particular location, if you plot them, you see that it makes this nice curve. That's the sine curve. It goes in one complete cycle from 0 to 2 pi. The highest number it achieves is 1, and the lowest number is -1. That means that its range is from 1 to -1. So I went ahead and they extend it. They said if you keep going past one cycle, it just repeats itself continuously and continuously. I highlighted some things here. The domain is from -infinity to infinity, which means it's going to go all the way that direction and all the way that direction. The range is from -1 to 1. The period is 2 pi. Once you get to 2 pi, it's going to start back over. And it is an odd function, meaning that the sine of -x is equal to the negative sine of x. You're going to be asked to graph several of these throughout this lesson. And they like for you to use 5 points, 5 key points. So here's how you find those points. The key points are found by dividing the period into 4 equal parts. Okay, so let's look here. We have the graph here of y equals sine x, and then we have the graph of y equals 2 sine x, and we made it taller. That one has an amplitude of 2, so it's taller. It still has a period of 2 pi. It completely does all of its cycle from 0 to 2 pi. So you'd want to look at this equation. It's y equals 2 times the sine of x. So the number that's located there is my amplitude. The period is found by dividing 2 pi by b. So our period here is just going to be 2 pi because our b value is 1. You can read through these examples and it will tell you how to set up your 5-number summary in order to find your key points. I wanted to show you this one. This is example 3. Determine the amplitude and the period of y equals 3 sine 2x. Then graph the function. Well, the amplitude is given right there. It's the absolute value of the coefficient of the sine, so it is the absolute value of 3, which is 3. The period is 2 pi divided by the b value. That's the b value in this problem. So it's 2 pi over 2, which is pi. That means that it's going to go through all of its cycle quicker. It's going to go through all of its values between 0 and pi. To find those values, we're going to start here. We're going to start here. X sub 1 is 0. X sub 2, your second point where you're going to find your value, is going to be x sub 1 plus the period divided by 4. Well, the period here is pi, so we're going to add pi over 4 to that. The third value, you're going to take the answer from here, not 2, 4, pi over 4, and we're going to add another pi over 4 to that. So it's going to give me 2 pi over 4 or pi over 2. Your fourth point, you're going to have pi over 2, and you're going to add another fourth pi. And if you change this one back to 2 pi over 4 plus pi over 4, you're going to get 3 pi over 4. Your fifth point would be 3 pi over 4 plus pi over 4, which is going to be pi. Well, that's going to be your ending point. So you're going to go all the way through your values from here to here. That's how you come up with the 5 numbers to evaluate your functions at. As we move on a little further, sometimes we have equations that have more going on in here, and they're going to have a phase shift. So what do we do to find the phase shift? Well, let's start finding our parts, and I'm trying, what have I done? I don't want this. So what we have here is an amplitude is A, the period is 2 pi over B, and the phase shift is C over B. So let's look at an example. We have an example here. This is example 4. Y equals 4 sine of 2x minus 2 pi over 3. Well, your amplitude is A. It is 4. Your period is 2 pi over B. There's your B value right there. So that's going to be pi. Your phase shift. Your phase shift is going to be C over B. Sometimes I'll say, well, take what's in the parentheses, 2x minus 2 pi over 3, and set it equal to 0. So if you added 2 pi over 3 to both sides, you would get 2x equals 2 pi over 3. If you divided both sides by 2, that's the same as multiplying by 1/2. You would get 2 pi over 6, which would be, we did that here, and it turned out to be pi over 3. So that's our phase shift. How does that affect our 5 numbers? Well, when we start down here with our 5 numbers, our x sub 1 is pi over 3. Instead of 0, it's pi over 3. Our period for this problem is pi. So each time we're going to add period over 4 to get our next number. So I'm going to say pi over 3 plus pi over 4, and you're going to have to get a common denominator. This one would be, let's see, 4/12 pi plus 3/12 pi. It's going to be 7 pi over 12. And then you're going to take that value, 7 pi over 12, and you're going to add another pi over 4. Well, pi over 4 is equal to 3 pi over 12, so then you're going to end up with 10 pi over 12, or 5 pi over 6, so you're going to get ready for the next one. You can list it however you want. If you want to list 10 over 12 pi and then add another pi over 4 to that, and you're just going to keep going that way. That's how you get your 5 numbers, and then you evaluate it each time, and that'll be your x value, and whatever sign is will be your y value. I want to encourage you to look at the e-text because we go through this same thing for cosine, and it's very much the same. You have a little bit different. Cosine starts at -1. It still has a period of 2 pi, but it does a little bit different movement than the sine. It's almost like the opposite of the sine. But I want to encourage you to go through and to look at what you have available. You can even print it off. You can't distribute it, but you can make copies for yourself. You paid for that textbook. You paid for that. So that's yours. If you have questions about particular problems, please email me and let me know, and I can help you with that. You'll probably want this handy, and you will want this handy as you move through this, this course. I hope you have a great day.